So I'm going to try and address everything absolute value. I'm going to start off kind of basic, and that's okay. The absolute value is the distance from 0. So the absolute value of 3 is positive 3 because the distance from 3 to 0 is 3. Negative 3. The absolute value of negative 3 is also 3 because the distance from here to here is positive 3. So the absolute value of a number is what is the value of that number. So if I said negative 7, the value of that number is 7. That's the absolute value. It just happens to be negative. But the absolute value of negative 7 is 7. Okay? And by the way, at any time, feel free to take pictures. I just don't have a constant note thing because I'm just going to use my whiteboard so I can kind of wing it. Okay? So I'm going to start off basic. And by basic, it means doesn't mean that if you don't understand it, you're basic. It just means from what I'm going to get to. Okay? If I have the absolute value of x minus 3 equals 5, I know that if I have the absolute value of negative 3 is 3, the absolute value of positive 3 is 3, that means xy, xy. I actually have two answers that could give me this. So I want to know what two numbers for x could give me that. Now some of you go, what? Okay, you'll memorize that absolute value means you have two answers. One answer based on what you're given. The other one, you can't really flip an equal sign over, so it still equals, and you make it negative. And then you just solve. X equals 8. X equals negative 2. If I asked you to graph that, you would go, hey, x equals 8 and x equals negative 2. There are two answers, this one or this one. If I actually asked you to graph this, this would be the point, 8, the y would be 5, and this would be x, negative 2 comma 5. So if I asked you to graph 8 comma 5 and negative 2, 5, okay, I'm going to step it up a little bit more. If I asked you to then put this in vertex form, you'd move that over. The vertex is 3, negative 5. Look at that. That's your absolute value graph. I'm trying to tie in vertex form to graphing to solving, all back to absolute value. Now, do you need to know all this green? No. But I want you to see that if you can see connections between everything, it'll make sense. So absolute value, I got two answers, I'm out. Now I'm going to change it, and instead of it saying equals, I'm going to say less than. So that means this is less than. That is less than. Instead of saying less than negative 5, I'm going to say greater than negative 5, which means now I'm going to say greater than negative 2. So now instead of this being closed circle, it's going to be an open circle on the 8, an open circle on the negative 2. What does that mean? If I say x is greater than 3, that means I have more than $3 in my pocket. I cannot have $3. I can only have more than $3. So I can have $3.01. So that's why it's open circle. Okay? Now, if it said less than or equal to, then it would be equal to, equal to, equal to, and those would be closed circle. Okay? Now I have to decide, are they shading away from each other or towards? Do I like red or blue? Or do I really like red and blue, which is purple? Or I like both of them. Okay? So we're going to decide that by graphing. So if I look here, x is less than 8, greater than negative 2. They are going towards each other. So what that means is I like both. Now, if I ask you how many answers you got, you would get many solutions. As long as the solutions are between negative 2 and 8, then that's a possibility. Negative 1 could be a possibility, 0, 1.5, but negative 3 is not a possibility. It's like I say, I'm thinking of a number between negative 2 and 8, and someone goes, negative 3. Okay, are you listening? All right, so it's that type of thing. What if this time, instead of it going less than or equal to, it was greater than. So that means this would be, let me move all this and change this around a little bit. I want you to see the similarities, okay? This would mean, I bring this down, greater than, greater than. But when we do this, we switch it, less than, and then that would be less than. I don't know, I can't keep track of my colors anymore. Then I would graph it, 0, 8, negative 2. It's not equal to, open circle, open circle. X is less than negative 2, greater than 8. So it's either red or blue. So it's either red or, oops, blue. So my number's either bigger than 8 or less than 2. Could it be 9? Yeah. Could it be negative 3? Yeah, that's less than negative 2. Could it be 0? No, that is not part of the solution. Now I'm going to say, what if it says, and I want you to see relationships between things. This time it says y is greater than x minus 3 minus 5. What would I do? Well, I know now, since I have an x and a y, I'm going to have a graph like this. We know what the vertex is. That's, oops, that's pretty. That's 3, negative 5. So right 3, down 5. I know because this is positive, it's going up. I know it makes a V. So, since that's true, it's symmetrical. Who should go in the center? The vertex. Now, I just pick numbers that are lower and higher. I know that this should match, and this should match. So I'm going to pick 4, but I could pick 2, but I don't like negatives. 4 minus 3 is 1. The absolute value of 1 is 1, minus 5 is negative 4. Now, if I say that's negative 4, that has to be negative 4. Remember how we had 2 answers? Okay. 5 minus 3 is 2. The absolute value of 2 is 2, minus 5 is negative 3. And I go dot, 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 dot. Now I have to make a decision. Is it either going to be solid or dashed? Okay. Since it just says greater than, it's going to be solid. And since it says y is greater than or equal to, I shade above. And that would be my answer. Now, what if this time it didn't say greater than, it says less than? What would be the difference? Oops, I'm sorry, I messed up. Sorry, this was greater than. And some of you are going to correct me. That should be dashed. Okay, so that would be dashed and going up. Sorry about that. What if it said greater than or equal to? Then it's solid. What if it says less than or equal to? Still solid, but this time it's shaded down. What if this time instead of less than or equal to, it just says less than? Dashed, 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 dashed. What if it said y plus 5 is less than the absolute value of x minus 3? Well, I would move the 5 over, and it would be y is less than the absolute value of x minus 3 minus 5. And then that's what that is. Okay? Hopefully that acknowledges things absolute value. Let me actually go a little bit further and try to think of another situation. If I had 3 minus the absolute value of 2x minus 1 equals 10. Okay? I can't split it until I get rid of stuff on the outside. So this would be minus 3. Then I'd be left with negative absolute value of 2x minus 1 equals 7. But I have a negative there, which means there's an imaginary negative 1. It's touching. Touching means multiply. The opposite of multiply is divide. And I would get 2x minus 1 equals negative 7. And some of you go, okay, well now I split it. No, don't split it. Because this is negative, absolute value can never equal a negative. There is nothing that will work. Now, I want to step it up. What if I gave you this, but this time I said y is equal to the absolute value of 2x. Let's just do this. Y, yeah, that's fine, equals the absolute value of 2x minus 1 plus 7. If you graphed this, it would be here, and it would be like that. So why was this answer no solution? Because when you graph this, it doesn't touch the x-axis. So I'm trying to find where does this cross the x-axis. And if you actually graphed it, it wouldn't at all. Okay. Now what does that mean? How could you graph this on Desmos? You could go y equals this, and then y equals this, which is really setting those equal to each other, and then you would see it doesn't touch. I think that's everything. Oh, nope, we still got more. Okay. If I had f of x equals 3 absolute value of 9 minus x plus 1, and I say f of 2. What do? You plug in 2. 9 minus 2 is 7. The absolute value of 7 is 7. Times 3 plus 1 is 22. That means f of 2 equals 22. What does that mean? That means that if you put this in Desmos and you graphed it, 2 comma 22 would be part of this v. So I'm just making it up, right? I don't know. And that is where it would cross. What if this time, instead of saying f of 2, I said f of x equals 4. Then this time I would take the 4 and I would plug it in for y. I know this is a lot. Well, there's a lot we've learned here and we don't even realize how much we've learned. Subtract 1. Divide by 3. Ah, we're at an equation. Split it. 9 minus x equals 1. 9 minus x equals negative 1. X equals 8. X equals 10. What does that mean in terms of graphing? When my x is 8, my y is 1. When my x is 10, my y is 1. If I asked you to graph this, 8, 1, and 10, 1, and you know it makes a V, well, look at this. Oh, sorry, that's not 8 and 1. Yeah, we're good. 8 and 10, 8, 1, and 10, 1. What's halfway between 8 and 10? 9. Vertex form, right? Okay, hopefully that's looking. This one looks a little bit weird, but it's pretty much the same thing. Okay, their vertex would be, I don't think it's there. I think it's up higher, but whatever. Okay? So when you're doing, actually no it is, because if I move this over, y equals the absolute value of 9 minus x, move that over minus 1, then your vertex is 9, negative 1, which is right there. That's why I have 2 answers for this one, because my y's. Hopefully that helped a little bit. Okay.